I am Mark, virtual teacher instructor at Egnatia Career College. Today we'll teach drainage waste and vent installation. This is video number 6. Drainage waste and vent installation. A plumber must consider all aspects of a plumbing system route before beginning the layout. Every job site has unique layout challenges. A plumber begins by identifying and laying out the fixture locations. Knowing where the sewer enters the house establishes the flow direction of the building drain. The location of the major fixture groups determines where waste stacks or fixture drains are routed, and how they will be connected to other piping segments of the DWV system. Knowing where the vents are terminated through the roof, and what fixtures will use air admittance valves (AAV), is essential for establishing the vent routes. If your local code allows wet venting, actual pipe routes are established for particular groups of fixtures. The fittings allowed by codes can also determine a pipe route, and the physical size of fittings can limit the chosen pipe route. Holes should not be drilled until the entire route is mapped out. This will prevent increased labor costs and eliminate unnecessary holes in studs and joists. In this section, we will look at a basic DWV layout of the above-ground rough-in for a house that provides some challenges. A plumber typically arrives on a job site when the framing is complete. In addition, any one-piece tub and shower units have typically been ordered and delivered to the job site. A blueprint indicates the fixture locations, but usually not the area of the building that is connected with the building sewer. The building sewer and building drain are connected at the low point of the building drain. When the plumber locates that, the main piping artery of the drainage system can be established. A plumber determines the building drain route based on job site conditions. Some job sites require the piping system to begin at the building drain exit location. Other conditions dictate that the piping must be installed so that the last connection of the building drain is made with the building sewer. Many plumbers install the piping on the floors above and stub all vertical drains into a basement or crawl space. Then they install the building drain. Personal preference plays a large part in the actual layout process. Most companies focus more on the productive installation of a particular job site or task than on whether the building drain is installed before the vertical piping. Scope of work. The scope of work is the total knowledge of the entire project, including the types of materials and fixtures and the design. You must locate all the fixtures throughout the house to understand the scope of work required to complete the DWV system. Then scan the entire bathroom or other related areas to determine a pipe route, focusing on the conflicts with structural designs such as beams, load-bearing walls, or joists. The unfinished crawl space area below the first floor would be a desirable pipe route due to its ease of installation. If the area below the first floor were a finished basement, the pipe route would have to coordinate with the design intent of that space. The location of underground vertical riser piping penetrating the concrete floor must take into account the pipe routes established to serve upper floors. Guest bathroom layout. The bathroom with only a toilet and sink is known as a half bathroom, half bath, because it has only a toilet and a lavatory. A full bath has a toilet, lavatory, and bathtub or shower. The toilet and pedestal lavatory are located along an interior wall with a stairwell directly behind the fixture. The water heater sits below the stairwell landing. Access must be provided, so piping can be installed in that area that is not in the center of the wall. Note the first floor guest bathroom fixture layout and the direction of the floor joists in the living room area. The stairwell wall continues through the floor above, which means that it might be possible to route the vent pipe vertically up to the attic. If the vent cannot be installed in a continuous manner in a wall, it can be routed within the second floor joists. Kitchen sink layout. The kitchen sink is centered directly below a window, and the exterior wall studs are load-bearing. If your local code allows an AAV, it can be installed below the kitchen sink to minimize labor costs. Eliminating the need to drill holes through the wall studs saves labor, but more important, the structural integrity of the wall is protected. If codes do not allow an AAV, the vent pipe can be routed in the exterior wall studs up through the second floor where it is connected with the venting system above or terminated independently to open air through the roof. The vertical drain pipe penetrating the floor can be located in the wall, or it can penetrate the floor where the cabinet will be installed. Where the pipe penetrates through the floor is typically coordinated with where the garbage disposer is located in the sink. The desired drain location is on the opposite side of the disposer, to allow for more creative piping possibilities during the trim-out phase. The rough-in using an AAV that has piping penetrating through the cabinet base requires only the pipe to stub up from the crawl space. The remaining piping is completed when the sink is installed during the trim-out phase. A typical sink cabinet base is 36 inches wide, but a plumber must confirm those dimensions on a blueprint. Master bathroom. It is not uncommon for an architect to locate the plumbing fixtures on the exterior wall of a house, which poses a challenge for the plumber. In such case, it is important for a plumber to know drilling and notching codes. For example, a 3 inches pipe that serves a toilet needs a 3 5/8 inches hole to be drilled through a joist, but some drilling and notching codes may not allow it where the layout requires. Fortunately, the joists in the example are traveling in a direction that allows the toilet piping to be installed between two joists. A plumber must approach a piping route to a bathroom group based on the piping requirement for the toilet. If wet venting is legal in your area, the lavatory drain and the vent for all the fixtures can be routed as a single pipe. If wet venting is not legal, a more difficult bathroom layout than the one illustrated in this lesson may be required. Individual vents would need to be installed. Exterior walls that have a 3 inches waste stack might have to be constructed with 2x6 wall studs instead of 2x4 studs to accommodate the 3 inches pipe and fittings. If a 2x4 wall is constructed, a plumber might have to find an alternative pipe route because he or she might not be allowed to cut the outside band joist enough for the 3 inches sanitary tee to be installed. An alternative would be to install the vertical piping in the interior wall of the stairwell, because the piping could still be routed in the direction of the second floor joists. Hall bathroom. The direction of the joists often dictates the pipe route. It might not be possible to drill through a joist to install a 3 inches pipe, because large diameter holes pose a threat to the structural integrity of a joist. Most codes dictate that a joist cannot be drilled in the top and bottom 2 inches, and many codes do not allow large diameter holes in the middle 1/3 of the joist span. A plumber often has to route the piping system serving a bathroom separately to avoid violating drilling and notching codes or to increase productivity. The toilet in the hall bathroom can be served by routing the 3 inches pipe in the same direction as the floor joists. This type of piping configuration would require wet venting if allowed. The bathtub located in the hall bathroom could be piped in 2 different ways. The bathtub piping had to be routed using a separate waste stack as shown in this picture. Most codes dictate that 2 inches pipe must slope 1/4 inches per foot. Connecting it to the same piping as the toilet would place the drilled holes for the lavatory through the floor joist in violation of the top 2 inches of the floor joist. Not all bathrooms can be constructed as designed. A plumber might have to provide an architect or general contractor with possible design changes. Laundry room. When a piping system must be installed on a level of a building other than the first floor, it must be routed to accommodate the design, which increases labor costs. As with all piping systems routed in a residential house, the direction of the floor joists is a primary factor in deciding where to install the piping. A plumber has 2 choices for this design. One is to drill through each joist, the other is to route the drain serving the washing machine in the same direction that the joists are installed. A dry vent must originate in the vertical position, true vertical to a 45 degrees angle. Your code may dictate the minimum and maximum vertical distances of the standpipe from a washing machine box to the inlet of a P-trap. Most codes state the minimum distance as 18 inches and the maximum as 42 inches. The actual installation of the P-trap is determined by codes, company preference, and specific job conditions. Some codes do not allow a P-trap serving a washing machine to be installed below the floor level. Also, many codes require the piping to be increased to 3 inches even though the P-trap can remain 2 inches, which emphasizes the importance of knowing your local codes. Building drain. Now that the piping layout of each fixture has been addressed, the building drain route can be established. A building drain is at the lowest horizontal portion of a DWV system and routes drainage discharge from all other drains to the building sewer. This isometric view of the piping system does not include any variables that would be required on a job site, such as the offsets around structural supports, heating and air conditioning units, or other obstacles a plumber might encounter. Venting system. The entire venting system includes every vent. Many vents are connected together to form a single vent, others remain as individual vents. The use of an AAV, if allowed by codes, terminates the vent where the AAV is installed. Other vents are terminated through the roof. That penetration is known as vent through roof, VTR. It is common for vents serving different areas of a building to be connected, but the most productive merging of vents is often in the attic. Most codes dictate that at least one vent in a system must be a minimum of 3 inches in diameter for the entire length of the vent. The 3 inches vent can be a continuation of a 3 inches or larger drain. As with any dry vent, it must remain connected to the drainage system in the vertical position. The height of the vent above the roof varies according to the climate conditions such as snowfall. A vent is routed throughout a house in walls and ceilings as a continuation of the drain it protects. Drilling and notching regulations are the same for venting as for drainage piping. Vent fittings are responsible for circulating air and draining moisture, as opposed to discharging wastewater. Most codes dictate that all fittings used in a vent system must adhere to drainage regulations. However, many codes allow variances in the fitting selection between these two systems. They allow standard radius fitting in a vent system where long radius fitting would normally be dictated if the piping were a drain. Terminating the vent pipe through the roof requires an oblong hole to be cut with a reciprocating saw from inside the attic. A plumber uses a level to align the pipe with the angled slope of the roof, and then draws an oval line to indicate the cut area. A hole can be drilled, and a reciprocating saw used to complete the cut, or a plunge cut can be made using the saw blade at an angle. The vent pipe is installed through the roof, and a plumber or roofing contractor installs the vent flashing on the roof. A roof sealant is placed under the flashing, and galvanized roofing nails are driven through the flashing and into the roof plywood. The most common type of roof flashing is made with neoprene. The center portion where the pipe passes through is flexible and conforms tightly around the vent pipe. Fixture rough-in. A plumber installs a piping system in a house based on the rough-in requirements of each fixture or group of fixtures. Each fixture has unique requirements. A plumber must use either typical company rough-in heights or manufacturer rough-in sheets to install drainage and vent piping. The size of each pipe serving a fixture is based either on the minimum requirements dictated by codes or on a company's preference of using larger size. A 1 1/4 inches pipe is the smallest size allowable in a DWV system, but most contractors do not install piping smaller than 1 1/2 inches. In other words, pipe sizing is based on codes and then is adjusted according to job site preferences. Many drilling and notching codes do not allow an adequate hole size to install a 1 1/2 inches pipe, so a 1 1/4 inches must be used in certain situations, such as serving a lavatory. The following information focuses on specific rough-in requirements based on common heights and distances. Toilets. The most common kind of toilet installed in a residential home has a two-piece design, with a separate tank and bowl. Some custom homes install one-piece toilets in the guest bathroom and the master bathroom. The two toilets have different water supply requirements, but the drain connection remains the same for both. The two most common rough-in dimensions for drainage piping are 10 inches and 12 inches from the back wall, but 14 inches might also be used for some toilet designs. The rough-in dimension is indicated when ordering by using the term rough. If a plumber does not specify a rough-in dimension, it is assumed that the drain is 12 inches from the finished back wall. Because rough-in occurs before the finished walls are installed, a plumber must know the thickness of the wall finish. Codes dictate that the center of the drain serving a toilet must be a minimum of 15 inches from a side wall or the side of another fixture for non-handicap installations. One side of a handicap installation must be exactly 18 inches from the finished sidewall that has the grab bar and a minimum of 18 inches from the other side wall or any partition or fixture. Handicap codes must be reviewed before installing a rough-in to make sure that it adheres to code. Before the final rough-in of a toilet drain, the plumber also needs to know the floor thickness. The toilet is connected to a drainage system with a closet toilet flange. The flange must be installed so that it is resting on top of the finished floor. Many new homes have either a vinyl or tile floor, and the toilet is installed after the flooring is complete. If vinyl is used, a plumber does not have to be concerned with additional floor thickness. If tile is installed, a plumber must know the exact thickness if the flange is installed during the rough-in phase. Many plumbers install the flange during the trim-out phase to ensure an exact installation. Others install it during rough-in, but leave the flange above the plywood. A tile contractor then installs the finished floor under the flange. A closet flange has 4 designated holes to receive non-corrosive wood screws. It must be fastened securely to the wood flooring to prevent the toilet from moving after it is installed. The hole cut into the floor must be properly sized to allow the piping and flange installation. A hole that is cut too large does not allow the securing wood screws to be installed. Lavatory. The 2 most common residential lavatory installations are pedestal and countertop designs. A pedestal sink has exposed piping. The center of the drain rough-in is installed so that it is in the center of the sink. A plumber must route the horizontal drain piping, waste arm, through the wall studs if the vertical piping is not located in the same area of the sink center. The piping to a countertop lavatory is not visible from the room, so a plumber can install the rough-in piping away from the center of the sink and complete the piping in the cabinet. A 2-piece P-trap has a 90 degrees portion and a J-bend portion that allows the J-bend to swivel away from the center of the stub-out piping. The size of the trap dictates the dimension of the trap swing. A 1 1/4 inches trap is the most common size installed for a lavatory. The average trap swing of a 1 1/4 inches P-trap is 3 inches. A plumber can install the center of a drain rough-in 3 inches on either side of the center of a countertop sink. This can save labor when the vertical piping is routed in a different wall stud cavity from the center of the sink. By not drilling an additional hole in a wall stud, less labor is used and the structural integrity of the wall is protected. Many pedestals have a small, designated area in which to install the drain connection that does not accommodate the swing P-trap. This figure compares a countertop and pedestal lavatory rough-in and shows that for a pedestal lavatory rough-in, a plumber must be more exact. Bathtub. If a 2-piece P-trap is used, the center of the rough-in piping can vary, similar to what is shown in this figure. A bathtub is typically connected during the rough-in phase of construction. The direction of the horizontal piping that is connected to the vertical stack depends on job site conditions. The location of the bath waste and overflow, BWO, depends on the tub design. The drain is usually connected to the P-trap within 2 inches of the wall. This close proximity to the wall as well as the physical size of a P-trap and the connecting sanitary tee often dictate that the rough-in of the vertical drain must be installed away from the center of the tub. If a horizontal waste arm is routed from a location that is not near the tub, the maximum allowable distance from a trap to the center of the vent is regulated by codes. These distances are listed in a chart in your local code book, most of which dictate that the 1 1/2 inches drain with a 1 1/2 inches P-trap cannot travel more than 5 feet. Some BWO designs have a dual connection option. A plumber can connect a dual option BWO to the P-trap using a trap adapter or a female adapter. Plastic female adapters should not receive metal male threads, because the female adapter could split. Kitchen sink. Kitchen sinks are installed in various locations, but the most common one is on an exterior wall directly below a window. Installing the drain and venting system poses a challenge if the exterior wall studs are 2 inches by 4 inches boards. The window has several load-bearing studs, and some codes may not allow the required hole sizes to be drilled. In addition, the vent cannot be transitioned horizontally until it is 6 inches above the flood level rim of the countertop, which is the rim of the kitchen sink. It is typically 36 inches above the finished floor. The wall space between the countertop and the bottom of the window typically does not accommodate the horizontal transition of the vent pipe. Most drilling codes do not allow more than 40% of a load-bearing stud to be drilled out. A 2x4 wall is 3½ inches wide. Therefore, a 1.4 inches, 1 3/8 inches, hole is the largest diameter that can be drilled, which does not accommodate the outside diameter of a 1 1/4 inches pipe. Some codes allow 60% of a load-bearing wall to be drilled if it is doubled with another wall stud. However, no more than 2 doubled load-bearing studs can be drilled consecutively. 60% of 3½ inches is 2.1 inches, 2 1/16 inches, which allows a 1½ inches pipe to be installed. A typical window frame is supported by at least 2 wall studs, and some inspectors require that additional studs be installed before drilling the window framing studs. Many local plumbing and framing inspectors do not allow 2 inches holes to be drilled through 2x4 exterior wall studs, so a plumber must use an AAV. The introduction and approval of an AAV has eliminated the need to install an individual vent to serve a kitchen sink. If a vent must be installed and the window framing wall studs can be drilled, a plumber has 2 options. One is to place the vertical drain and vent in the wall cavity adjacent to the window, and to install a waste arm to the sink location. The other is to install the vertical drain below the window and offset a 1¼ inches vent at a 45 degrees angle into the wall cavity adjacent to the window. The 45 degrees installation of the vent means the holes must be drilled at an angle into the wall studs, which is more labor intensive than drilling straight through a wall stud. Washing machine. Washing machine boxes are installed during the rough-in phase between 2 wall studs. Most codes dictate that the minimum size drain connection of a box, whether plastic or metal, is 2 inches. Plastic types are solvent welded. Most metal ones have female threads that receive a male adapter to connect to plastic DWV pipe. Most codes do not allow plastic boxes to be installed in a fire-rated wall. The P-trap is installed within the wall stud cavity either below the washing machine box or below the floor, but some codes mandate that the trap must be installed on the same floor as the washing machine. The UPC also mandates that the trap on the same floor must be no closer than 6 inches or further than 18 inches above the floor. The vertical pipe that is connected from the washing machine box to the P-trap inlet pipe is the stand pipe. The IPC states that the stand pipe cannot be shorter than 18 inches or longer than 42 inches, but UPC states 18 inches and 30 inches, and that distance is above the trap weir. The height of the washing machine box may also be regulated by codes, with some codes stating that the overflow height of the box must be at least 36 inches and not more than 42 inches from the floor. Some codes dictate that a washing machine installed on any floor with an occupied floor below must have a safety pan. A plumber installs the drain piping for a safety pan during the rough-in phase. A pan is installed during the trim-out phase. The safety pan drain is typically 1-inch copper or plastic pipe made of water distribution materials. It does not have to comply with drainage fitting regulations. The drain typically terminates on the exterior of the house and cannot directly be connected to the drainage or vent system. Check your local codes for termination locations and heights of the washing machine safety pan drains above the ground. Shower pan. A shower has a P-trap similar to a washing machine. Some codes allow a 1½ inches trap to connect a shower, others dictate a 2 inches minimum trap size. The drain assembly for a one-piece shower unit or a pre-molded shower base is typically provided with the unit. The piping exiting the shower floor is connected with a P-trap located below the floor. Most codes require a tiled shower located on a wood floor or above a area to have a safety pan installed, so a plumber must install a 3-piece shower drain. The most common type of safety pan is a PVC liner, which is installed by a plumber during the rough-in phase. The actual installation techniques may vary by preference, and the location of securing nails to the wall studs may vary based on local codes. Some tiled showers have a seat, and a plumber must protect that wood structure from water damage with the same PVC liner material. Galvanized roofing nails are frequently used to secure the pan to the wood stud and seat. A threshold is constructed in the entryway of a shower, and a plumber terminates the safety pan or over the threshold. Hangers and supports. Like water distribution piping, drainage and vent systems must be supported. Codes determine the spacing between hangers based on horizontal or vertical installation positions. Additional support is installed where necessary to ensure that a pipe does not sag. Band iron is the most popular means of supporting residential DWV piping because plastic piping is very light-weighted and band iron increases productivity. Galvanized nails or drywall screws are often used to fasten the band iron to the wood structure. Band iron is available in rolls from 10 feet to 100 feet in length. Some plumbers use 1/4 inches bolts and nuts to provide a higher quality installation, but that method increases material and labor cost. The bolts are typically 1 inch long and are galvanized or have another type of corrosion-resistant coating. The attachment methods for various hanger installations are the same for DWV piping as for water distribution piping. When piping is hung in an attic, additional wood must often be added to the ceiling joist. Small pieces of wood in varying thicknesses can be added to the top of the joists to allow the pipe to slope. Another method is to cut longer boards and secure them to the sides of the ceiling joists to control the slope, and then use band iron to secure the pipe to the wood. A more labor-intensive method of supporting horizontal pipe from a ceiling or floor joist is to drill the appropriate size hole through a board and then secure the board to the joists. Pipe protection. Like water distribution piping, DWV piping must be protected against nails and screws used to install wallboard and wood trim during the final phases of construction. A metal stud guard, nail plate, that protects the piping is available in several sizes. Most have a nail-in feature to drive into the wood boards with a hammer. A 3 inches pipe that penetrates the top plate of a 2x4 wall requires the top plate to be cut completely in half. Removing this top plate can weaken the wall, and an angled iron plate may be required by codes. The plate must be fastened to the wall studs on both sides of the cut area and to the floor or ceiling joists. Most codes dictate the burial depth of drainage piping. In colder climates, drainage piping must be buried deeper than in warmer climates. A drainage pipe can freeze if it is not adequately protected from cold temperatures. A vent through a roof can become closed with frost, so most cold regions have a frost enclosure code that dictates the size that vent pipe can penetrate a roof. Because special protective measures may be required based on certain local conditions, a plumber must know local codes. Earthquake regions are regulated with seismic codes and may require unique pipe protection codes. Connection to dissimilar pipe. A connection between dissimilar pipes is not as common on a new construction site as on a site that has been repaired. Connecting the plastic DWV pipe inside the house to a municipal sewer may require a transition between two different materials. Many custom homes use a cast iron pipe installed vertically in a wall to provide a more silent water flow through the pipe. The transition between cast iron and plastic can be achieved in two ways. A transition coupling is a rubber sleeve with stainless steel tightening clamps that creates a watertight connection. Using a transition coupling may not be legal in a house. Many codes allow their use only below ground. A cast iron pipe installed in the vertical position places all the weight of the pipe downward onto the connecting pipe. All codes approve of a specialty fitting designed to connect plastic DWV pipe to no-hub cast iron pipe. The adapter is solvent welded, glued, onto the plastic pipe, and a no-hub clamp, coupling, connects the adapter to the cast iron pipe. Threaded male and female adapters used to connect various dissimilar pipes are approved by all codes. Copper DWV pipe is not often used for residential drainage and vent installations, but when it is, it can be connected to other materials with a brass DWV male or female adapter. A unique clamp, coupling, similar to a no-hub clamp, is available and approved by most codes to connect DWV copper to cast iron. A no-hub clamp and transition couplings are offered in various sizes, including reducing sizes to connect two different sized pipes together. Testing DWV systems. DWV pipe and fitting must be tested using a test method determined by codes. The most common is a water test in which a plumber fills the piping system with water and then visually inspects it. Most codes dictate that a 10 feet head of water must be used to apply about 5 pounds per square inch (psi) of pressure above the highest connection. Some codes allow a plumber to install a 3 feet head of water above the highest drainage connection, and do not require that the vent system be tested. Still other codes state that the entire drainage and vent system must be filled with water up to the highest vent through the roof. Extremely cold regions must fill the system the same day as the inspection so that the DWV system does not freeze. Some codes allow an air test to be applied with 5 psi when water is not available, but most plastic piping manufacturers caution against using air for testing their products. Caps, test balls, and test plugs are used to seal pipe ends and portions of piping systems to allow the pipe to retain the water or air. Solvent-welded test caps are used to seal plastic piping ends. With a test tee, a blow-up rubber test ball is inserted into the pipe and air is injected into the ball to expand inside the pipe. Test balls are available in the same sizes as DWV pipes and can also be used to seal a pipe end. Test balls are available in 2 different lengths, and most cannot be subjected to more than 40 psi or whatever the manufacturer states. Rubber test caps with a stainless steel clamp and worm drive screw, similar to a transition coupling, can also be used to seal a pipe end. This figure illustrates the 10 feet head test that is used to inspect a system for leaks and prepare it for a plumbing inspection.